So कोई आउटपुट आया है?
Okay. So let me start from where we left. हम कुछ exercises कर रहे थे. उनमें से एक हमने last time किया था, क्या था वो? जिसका मैंने बोला था वो that's obvious rather, लेकिन हम उसके बगैर भी वो यूज किए बगैर भी उसको कर सकते हैं. मैंने यूज किया था ये शायद. The limit of n plus 1 raised to power 1 by n as limit n approaches infinity is equal to 1. Now this can be proved easily if you know about the logarithms. And we have to use the continuity of the logarithm, and it's, you know, it preserves the order. So अगर वो हम वैसा करें, because then it would be easy. लेकिन अगर हमें वो नहीं पता, अगर मैं इस पे log लगा दूं, you will get 1 by n. This would be 1 by n log of n plus 1. So that would be log of n plus 1 divided by n. And if I take its limit as n approaches infinity, it's infinity by infinity. So by L'Hopital's rule, this should be, we should differentiate the numerator and denominator separately and then take the limit. And this should be equal to, by L'Hopital's rule, 1 by n plus 1 divided by 1, which is limit n approaches infinity 1 by n plus 1. अगर मैं यहाँ limit साथ में लगाता जाऊँ, limit n approaches infinity, so that's equal to 0. So we put log of something. अगर तुम्हें मिले इस तरह से कि log of n plus 1 raised to power 1 by n goes to 0 as n approaches infinity, using the continuity of the exponential function, it would imply that e raised to power log of n plus 1 raised to power n goes to e raised to power 0, that's equal to 1. So which means that log or exponential cancel out होंगे, that this इसका limit 1 है as n approaches infinity. शायद तुम में से किसी ने कहा भी था, लेकिन अगर हम वहां डायरेक्टली रेशियो टेस्ट भी लगाते तब भी वो चल जाता, बजाय वो कोशीज रूट टेस्ट के. अगर हम डीएलएम-बोर्ड रेशियो टेस्ट लगाते तब भी हमें वही रिजल्ट मिलता. तो अब तुम्हारी मर्जी है, या तो ये यूज करो जो हमने किया कि ये लिमिट 1 है, या फिर यू जस्ट यूज इन दैट क्वेश्चन डायरेक्टली डीएलएम-बोर्ड रेशियो टेस्ट. उसमें हमें फिर ये परेशानी नहीं. ओके ओके, और कोई, हम कहाँ पहुंचे थे मुझे याद ही नहीं. हाँ, फिर मुझे लगता है हमने ये किया था. There was this exercise, it was root n. यहाँ पे मैंने बोला था चलो कल करते हैं. So this is my an, and I want to see whether the 3 summation an converges or diverges. Under what conditions? So divided by n square plus 1. Let n be this. Again, this would be done by ratio test. So because an plus 1 divided by an किसके बराबर होगा? It would be root of n plus 1, root of n plus 1, x raised to power n plus 1 divided by root of n plus 1 का square plus 1 multiplied by root of n square plus 1 divided by root of n into x raised to power n. So this is the ratio, and if I take the limit, as I can see, then I can write it as limit n approaches infinity. So this would be what? xn, x बचेगा खाली, इसको इसके साथ लाते हैं. So it would be n plus 1 divided by n multiplied by root of n square plus 1 divided by n plus 1 का square plus 1 multiplied by x. Now this can be written as limit n approaches infinity, square root of 1 plus 1 by n multiplied by square root of dividing both numerator and denominator by n square. So you should be 1 plus 1 by n square divided by 1 plus 1 square plus 1 by n square multiplied by x. And as you can see, this thing is 1, this thing is 1 as n approaches infinity because they become 0. So this should be just x. So therefore, by D'Alembert's ratio test, the summation an and runs from to infinity converges if x is less than 1 and diverges if x is greater than 1. Question is at x equal to 1 kya hoga? Now in case x is equal to 1, then an would become root n divided by root of n square plus 1. And this would be approximately, that should behave as summation 1 by root n. So therefore this will diverge. Because if I compare it with, so if I take bn to be 1 by root n, so ratio test जो इससे पहले हमने किया था दूसरी comparison test या ratio test whatever. So if I compare the two, somebody raised hand क्या है? You can say also. किसी ने कुछ पूछा? So I presume अगर किसी को कुछ पूछना है तो you can stop me, no issue. Now look at this, अगर bn इसके बराबर है, then an by bn is equal to 1 by root of n square plus 1. And if you take the limit as n approaches infinity, right? So this would be 0 to infinity. So I've got an divided by bn, root n cancel. तो ये तो 0 आ जाएगा. So and हाँ बिल्कुल ये 0 आ गया. And since जो denominator में ये जो bn वाली series है, summation bn n runs from 1 to infinity diverges. Therefore, summation n runs from 1 to infinity diverges. So therefore, x equal to 1 के लिए भी decide हो गया. Therefore, I can say that summation n runs from 1 to infinity converges if x is less than 1 and diverges if x is bigger than or equal to 1. Okay. ठीक है. Because this series diverges, you know that by p test. हमने किया है summation 1 by n raised power p diverges if p is less than or equal to 1. Of course, this is actually 1 by n raised power 1 by 2. And 1 by 2 is less than 1. Okay, next इस पे दिया है इसने. Let's do it. So I've got an is equal to an is equal to 1 into 3 into 5, so on and so forth, up to 2n minus 1 divided by 2 into 4 into 6 up to 2n multiplied by 1 by n. तो पहले इसको ratio test check करेंगे हम. So an plus 1 would be equal to 1 into 3 into 5 into 2n minus 1. उसके बाद आएगा n को अगर हम n plus 1 देंगे तो it would be 2n plus 2 minus 1, so it should be 2n plus 1. So in the denominator, I should have 2 into 4 into 6 into 2n into 2n plus 2 into 1 by n plus 1. And if I take the ratio, an plus 1 divided by an, what do I get? काफी सारा कुछ cancel होगा, बचेगा खाली I think 2n plus 1 divided by 2n plus 2. अब यहाँ है an नीचे है तो n ऊपर आएगा, so it should be n divided by n plus 1. And if I take the limit as n approaches infinity, so I think this would be 1. And ratio test fails. Again, if I use the Raab's test, if I take limit n approaches, so ratio test fails. या अगर मैं लेता हूँ राब्स टेस्ट, सो राब्स टेस्ट के लिए मुझे क्या लेना है, ए एन divided by an plus 1 minus 1 multiplied by n. So ये बन जाएगा n into, इसको देखो क्या मिलेगा, it would be n plus 1 into 2n plus 2 divided by